Have you ever wondered what lurks in the darkest corners of the universe? What if there were stars that defy everything we know about physics? Welcome to the hidden world of dark stars, a cosmic enigma that could rewrite our understanding of the universe. These are not stars in the traditional sense. They don't shine like our sun. They don't burn through nuclear fusion. Yet they may hold the key to the universe's earliest secrets, possibly even the secret of existence itself. Let's unravel the mystery. Let's dive into the science. And let's explore how dark stars might reshape our understanding of space, time, and everything in between. The cosmic canvas. The universe is vast, ancient, and full of light, but also full of shadows. When we peer deep into the cosmos, we see stars, galaxies, and brilliant nebulae. But between these shining beacons lie immense voids of darkness. For decades, astronomers believed these voids were simply empty space. But what if they aren't? What if hidden within those shadows are ancient giants, dark stars, formed not of ordinary matter, but something far more exotic? Something we call dark matter. What are dark stars? So, what exactly is a dark star? Contrary to what the name suggests, a dark star isn't a collapsed star like a black hole. Instead, it's a hypothetical type of star that formed in the early universe, before galaxies, before planets, maybe even before light itself. Unlike traditional stars that shine by nuclear fusion, dark stars may be powered by dark matter annihilation. Dark matter, which makes up about 85% of the universe's total mass, doesn't interact with light. It doesn't emit, absorb, or reflect radiation. It's invisible. But under certain extreme conditions, dark matter particles could collide and annihilate each other, releasing vast amounts of energy. This energy could, in theory, power a massive star, a star made mostly of ordinary hydrogen and helium, but with a dark heart. A dark star. The origin of dark stars. Scientists believe dark stars may have formed just a few 100 million years after the Big Bang. At that time, the universe was still a swirling soup of particles. There were no stars yet, just matter, radiation, and the mysterious presence of dark matter. Where dark matter was most concentrated, it pulled in hydrogen gas through gravity. Instead of immediately igniting into fusion, these dense pockets of matter may have started to glow, not because of nuclear reactions, but because of dark matter heating. This strange heating process could have created enormous, puffy, and relatively cool stars, up to 1 million times the mass of our sun. Imagine that for a moment. A star the size of a galaxy, glowing dimly, silently, invisibly. How are they different from normal stars? Traditional stars are hot, compact, and bright. Dark stars, by contrast, could be cooler, more massive, and larger in volume. They wouldn't emit strong visible light. They would glow faintly in infrared wavelengths, making them incredibly difficult to detect. But this also makes them fascinating candidates for James Webb Space Telescope (JWST) observations. Some scientists believe JWST might already be seeing hints of these elusive giants in the early universe. A few bright infrared objects found in the deepest images might, in fact, be dark stars rather than galaxies. If confirmed, this would be one of the biggest discoveries in cosmology ever. The role of dark matter. The key to understanding dark stars lies in unlocking the secrets of dark matter. We don't know what dark matter is made of. It doesn't behave like any particle we've ever studied. But if dark stars exist, they could provide natural laboratories to study dark matter in action. They would offer the first direct observational evidence that dark matter can affect the evolution of stars, and possibly of galaxies too. And it doesn't stop there. Some theories suggest that dark stars might collapse into supermassive black holes, forming the seeds of the colossal black holes found in the center of galaxies. This could explain how black holes, billions of times more massive than our sun, formed so early in cosmic history. Why should we care? You might wonder, why does any of this matter? Well, dark stars could fundamentally change our understanding of the early universe. They could explain how the first structures formed. They could help us understand dark matter, one of the biggest unsolved mysteries in physics. And perhaps most importantly, they could show us that the universe is far stranger and more wonderful than we ever imagined. Could there be dark stars today? Most models suggest that dark stars were short-lived. Once dark matter ran out in their cores, they would have collapsed or ignited fusion like ordinary stars. But some researchers speculate that long-lived dark stars might still exist in the present-day universe, drifting invisibly through space. If so, we might one day detect one, perhaps through gravitational lensing or infrared surveys. And that discovery would mark a new chapter in astronomy. The ultimate question. So now, let me ask you again, what really lurks in the darkest corners of the universe? Are dark stars just theoretical ghosts from a forgotten past? Or are they ancient sentinels, quietly watching as the cosmos unfolds? Maybe, just maybe, they hold the missing piece to the cosmic puzzle. And maybe, they've been there all along, just beyond the light. Thanks for watching Space Knowhow. Don't forget to like, subscribe, and turn on notifications for more journeys into the unknown. Until next time, keep your eyes on the stars and your curiosity even higher.